Okay, so here's a set of data that I'm going to be doing Pythagorean theorem with, and then some analytics on, or analysis of, because just given a set of data, I want to know how tightly is this grouped, and I want to know how far off, generally speaking, did this occur. So when I talk Pythagorean theorem, writing it out, it would be a squared plus b squared equals c squared. And for the sake of this, I'm going to break it into steps, just so it's easier to see. So the first step, I'm going to put my a squared, which I'll do x squared, and then y squared. So a squared b squared equals c squared. Now c squared is going to be the final distance. So this will be my calculated distance. There we go. So for x squared, what I'll type in here is, rather than doing the math and putting it in manually, I'm going to have Excel do the math for me. So I'll type equals so it knows I'm doing math. Then I'll click over here on the A2 spot. Now I could type that in. I just like clicking on things. It makes it a little bit faster. So that Shift 8 will give me the multiplication sign, and I'll hit that again. So A2 times A2 is going to be squaring that number that is in that cell, which is what that is there. And for here, I'll do equals. This is y squared, so y b2 times b2. So I'll hit enter. So this is a squared, which is x, and then b squared, which is y. Calculate distance, put it equals. Now because I want to know the distance and not c squared, I'm doing the square root. SQRT gives me that. And I want the square root of the sum of these two numbers. So I'm going to click on this first one, shift equals to give me the plus sign, then y squared, because I want to add those two numbers. So it's going to add those two first because they're in parentheses, and it'll square root them. So doing that gives me 25. Now if I highlight the three of those numbers, there's a small green circle on the bottom here. If I hover over that, my cursor will change to a smaller plus sign. If I click there and drag down, it's going to give me basically everything done. Completely just done for me. So this is just calculated all the way down. And then on the bottom here, I want to do something to help me summarize this. Because yes, I've got now the calculated distance, but at this point I want to do some math to help me get a little bit better summary. So I'm going to do the average, and I'm going to do the standard deviation. All right, I'll explain those two numbers in a moment. All right, so the average number, I'll type equals average is a function that it knows, and then open parentheses, and I'll highlight all the numbers in that column. Oops, I don't want the top, so I'll bring that. Oops, oh boy. I only want to have the numbers selected. I just don't want any issues with that. So calculate the average of those numbers. In this case, G2 to G26. I'll hit enter. So that's the average. So if these are distances away from hitting the target, this is a good one number summary of, generally speaking, how close did they come to hitting the target. It doesn't tell me, though, how tightly clustered these were. So were they kind of around the general vicinity of the target, or were they all over the place? Standard deviation is going to give us how far off of each other the points were. So the standard deviation, if these were all missing but very tightly packed, would be low. But if they were all over the place, the standard deviation would be bigger. So equals stdev, open parentheses, select all those, then I'll hit enter again. So what this is telling us is the average distance away is this number, but then the average distance from the average is 12. So I'm just going to play with some numbers here quickly, just so you can see what I'm talking about. So if we're talking, this is just going to be a made-up scenario, just to explain these a little bit. And I did this in class, just explaining this. So if the made-up numbers, let's just say I had 5, 5, 5, 5. If these were just all the distances, maybe a couple sixes. Most of these numbers are about the same. 5, 5, 5, 5, 5, 5. Okay. If those are all my numbers, if I want the average of those, the average should be about 5, because most of these numbers are 5. So these made-up numbers here, okay, 5 point a little bit. I threw some 6s and 4s in there. That's giving me the average. So the average of all these numbers is that. Now if I put the standard deviation of these numbers, they're almost all the same number. So this is going to be really low. That's a pretty low number. If they were all 5, the standard deviation would be 0. Because there's no difference between any of these numbers and the average number, which is 5. But as you add other numbers in, it's going to increase the standard deviation, and the average is going to be somewhere in the middle of all these numbers. So hopefully that clears up what standard deviation is just a little bit. We're going to use these numbers to help compare how different groups do as far as how they hit the target, whether they were the most precise or the most accurate, were they really, really good at hitting a tight cluster, or were they really, really good at actually hitting the target, and kind of who overall was the best at hitting the target on those. So that's the first step of what I'm having students do for statistics using Excel. Let me know if you have any questions.